What if I told you that a zebra's stripes go much deeper than what meets the eye? That beneath that iconic black and white coat lies skin that's perfectly, permanently striped too? Picture this. You're on safari, watching a herd of zebras grazing under the African sun. Their stripes ripple as they move, creating that mesmerizing optical illusion we've all seen in documentaries. Now imagine one of those zebras shaved completely bald. What would you see? Not plain pink skin like most mammals, but skin that mirrors those exact same stripes, dark skin under the black fur, light skin under the white. This isn't some rare genetic fluke. It's true for every single zebra born. And it raises a fascinating question. Why would nature go to such lengths to stripe an animal? Underneath everything, to understand why zebras have striped skin, we first need to rewind and look at what we thought we knew about their famous coats. For years, scientists debated why zebras evolved stripes in the first place. The leading theories were pretty straightforward. Maybe the stripes helped with camouflage in tall grass, or confused predators during a chase, or even helped zebras recognize each other. Some researchers suggested the stripes regulated body temperature by creating tiny convection currents. But all these theories had one thing in common: they were about the fur. Nobody was really asking what was happening beneath the surface. That changed when veterinarians and wildlife biologists started treating injured zebras. During surgeries or necropsies, they made a startling discovery. The skin itself was pigmented in perfect alignment with the fur pattern. This wasn't just a surface-level feature. It was baked into the zebra's very biology. And that realization shifted the entire conversation. Because if the stripes were only for external functions like camouflage or social signaling, why would the skin need to be striped too? The answer, it turns out, lies in the zebra's embryonic development, a process so precise it programs the pattern right down to the cellular level. Let's dive into how this actually works. Every zebra begins as a single fertilized cell. As that cell divides and the embryo forms, special cells called melanocytes start migrating across the developing skin. These melanocytes produce melanin, the same pigment that gives color to human skin and hair. In most mammals, these cells spread evenly, resulting in uniform skin tone. But in zebras, something different happens very early on. Genetic instructions activate that create an invisible map, a blueprint of stripes, before the hair follicles even develop. The melanocytes don't spread uniformly. They cluster in certain areas and avoid others, creating alternating bands of high and low pigmentation. This pattern is locked in before birth and remains for life. The fur that grows later simply follows the skin's pre-existing template. Dark fur grows from dark skin, white fur from light skin. It's like the skin is the canvas, and the fur is the paint that perfectly matches the underlying design. But why would evolution favor such a detailed, two-layered system? One compelling theory involves protection, not from predators but from the sun. Zebras spend most of their lives exposed to intense African sunlight. Their dark stripes absorb heat while their white stripes reflect it. But what about their skin? If they had uniformly dark skin under white fur, those areas would be more vulnerable to UV damage. By matching the skin pigmentation to the fur, zebras may have evolved a kind of natural sunscreen, dark skin under dark fur to handle direct sun exposure, lighter skin under white fur where less protection is needed. This precise alignment could help prevent sunburn, reduce heat stress, and even lower the risk of skin cancers over a lifetime under the blazing sun. there's another layer to this story: the role of stripes in zebra social and individual identity. Each zebra's stripe pattern is as unique as a human fingerprint. Mothers and foals recognize each other by these patterns. But what if that identification begins even earlier? Some researchers suggest that the skin stripes might play a role in prenatal development, helping to establish the unique patterning that will later become so important for social bonding. The skin stripes could serve as an anatomical guide during fetal growth, ensuring that the final coat pattern develops with perfect precision. This would explain why the skin patterning is so exact. It's not just a byproduct, but an essential part of creating each zebra's distinctive identity from the very beginning. Now, here's where it gets really interesting. Zebras aren't the only animals with patterned skin matching their coat. Some domestic cats, certain dog breeds, and even dairy cows can show similar skin pigmentation patterns. But in zebras, this trait is universal and perfectly executed in every individual. This suggests that in zebras, the striped skin serves multiple purposes simultaneously: thermal regulation, UV protection, and precise pattern development. It's nature's way of building in redundancy, ensuring that even if the fur is damaged or shed seasonally, the underlying protection and patterning remain intact. The resolution to this striped skin mystery reveals something profound about how evolution works. It's not just about solving one problem at a time, but about creating systems that address multiple challenges simultaneously. The zebra's striped skin likely evolved as part of a package deal. The same genetic mechanisms that create the visible stripes for camouflage and social signaling also build in sun protection and ensure pattern precision at the deepest level. This multi-layered approach is what makes the adaptation so successful. It's why zebras can thrive in environments where other similarly sized mammals might struggle with heat, UV exposure, or social confusion. When you step back and look at the big picture, the zebra's striped skin becomes more than just a curious biological fact. It represents evolution's genius for efficiency, solving several problems with one elegant solution. The skin isn't striped by accident or as a meaningless byproduct. It's an integral part of what makes a zebra, working in harmony with the famous coat to help these remarkable animals survive and thrive in their challenging environment. The next time you see those beautiful black and white patterns, remember, you're only seeing half the story. The real magic is hiding just beneath the surface, a permanent reminder of nature's attention to detail. What other animal mystery should we uncover next? Drop your suggestion in the comments, and don't forget to subscribe to Animal Fact Vault for more revelations from the natural world.